All right, so again, remember we split this into two parts. We did everything up to slant asymptotes yesterday. We're going to finish that today. We'll do slant and holes today. But your quiz will cover up until that point. So vertical asymptotes, horizontal asymptotes, domain, zeros, y-intercepts, that kind of stuff. So number one says find the vertical and horizontal asymptotes for the graph of the rational function, then graph the function. So when I look at this, the first thing I'm going to do is factor the denominator, and I get x plus 4 and x minus 4. Set them each equal to 0 to get my vertical asymptotes, which happen at negative 4 and positive 4. So those are my vertical asymptotes. Remember, they need to be in equation form, and vertical is x equals. So tomorrow's quiz is multiple choice, so hopefully you won't not mess up the equation form part. Like on the test, if you get an open-ended question, you have to make sure you put the x equals. But how tomorrow's multiple choice will get you is that one of your answers would say y equals negative 4 and y equals positive 4. And obviously you can't pick that one, right? Because vertical would be x equals. So when I go to put those on the graph, they would look like this and like this. Those are going to be your vertical asymptotes. Horizontal asymptotes, we look at the exponents. What happens when they're the same? You do the leading coefficient. So my horizontal asymptote would be y equals leading coefficient in the top, which is 4, over leading coefficient in the bottom, which is 1, or y equals 4. And that's where you get your horizontal asymptote. Then we got to know what's happening in between. And one of the ways you can do that is to find your zeros, to use your symmetry, like all those other ways to do it. Your quiz is going to ask you for domain. So remember, like domain is where the vertical asymptotes would be. So it would be from negative infinity to negative 4, negative 4 to positive infinity, and 4 to positive, negative 4 to 4. And then 4 to positive infinity. So make sure you'd be able to do that. To find the zeros, we'd set our numerator equal to 0, and I'd end up with 4x squared equals 0, x squared would equal 0, and x would equal plus and minus 0, which tells me it's going to hit 0 and it's going to bounce at 0. So it's going to have that parabola shape in the middle. The fact that this would have y-axis symmetry also helps confirm that that is the shape that I want in the middle, because whatever happens on the right is going to reflect onto the left. So now, because the parabola points down, the other arrows have to go the other direction, which means my curves are going to be up here. One, you know that if you've graphed these, that if it's a parabola going in one direction, the other ones go the other way. Two, there's no other zeros on these parts of my graph, so it can't cross through there. Three, I could take and plug in something like 6, or where was this? This was at 4. So I could plug in 5 or negative 5, and it would confirm that I'm above the x-axis. So this would have been 5 squared minus 16. This would be 4 times 25 over 25 minus 16, or 100 over 9. That's obviously bigger than 4, which confirms that my curve should be above the horizontal asymptote. So in each of those sections, you got to figure out, am I going above or below the horizontal asymptote, and then what's my middle graph look like? We're going to do some more practice with that today, but questions so far? All right, so continuing on, like I said, 2, 6, and 2, 7, 2, 6, and 2, 7. It is all about rational functions. It's going to include rational functions. There's zeros, the domain, vertical asymptotes, horizontal asymptotes. So we talked about holes a little bit yesterday. A hole is when you cancel something out. So in the example yesterday, you had like x plus 2 over, and once you factored x plus 2 and x minus 2. If you can cancel out a factor, like in this case, the x plus 2 is canceled. I think it was plus or minus, whatever it was. Whatever cancels there gives you the x coordinate of your hole. So if I set this equal to 0, I would have gotten a hole at negative 2. And then to find the y coordinate of your hole, you plug that value back into your updated function. So after I cancel this out, this becomes 1 over x minus 2. If I take the x coordinate and plug it back in, I'd get 1 over negative 2 minus 2, or negative 1/4. And I would have a hole on the graph at that point. So that's what a hole will look like. Again, we're going to get some practice at the end. We'll put it all together. But that was on yesterday's slide. We just talked about it real brief, okay? So now in the order, and we talked about this yesterday, but in the order of things we're going to do, step 1 is always to factor them. But now step 2 is to find domain, and step 3 is to look and see if you can cancel things out. If you can cancel something completely from the bottom, it creates a hole. And then we left off here, which is slant asymptote. So a slant asymptote is exactly what it sounds like. It's an asymptote that is slanted, so it's going to be a line. It can have positive or negative slope. It's going to be slanted in some direction. but it only occurs if the degree of the numerator is 1 more than the degree of the denominator. So if n, which is what we call the degree in the numerator, is 1 more than m, which is what we call the degree in the numerator, then you do not have a horizontal asymptote, because if it's bigger in the top than the bottom, you can't have a horizontal asymptote. And in this scenario, you have a slant. The way we find slant is literally dividing out our terms. So I would divide the numerator by the denominator. And you can either use long or synthetic depending on what it is. If it's long division, then whatever's at the top without the remainder, we set equal to y, and that's going to be your slant asymptote. We literally ignore the remainder when we get slant asymptote. And it should be in y equals mx plus b form. So because it's only 1 more, your x is going to be raised to the first power. If it was like x to the fourth in the top and x to the second in the bottom, then there's neither horizontal nor slant. Can only be 1 more. All right, so example 6 says, find the slant asymptote of the function. First of all, you'd have to be able to identify there is slant because the exponent is 2 in the top and 1 in the bottom. So it's 1 more. Now I need to divide. You have 2 options. Either divide using long division. You'd have to make sure you add in your plus 0. Or because it's just x to the first, you can actually use synthetic. So this would be plus or minus 0. It doesn't really matter because 0 could go on the outside and it doesn't carry a sign. And then I write out all my coefficients, 1, 6, 2, bring down the 1, multiply it times 0, put it in the next column and add it. Multiply it by 0, put it in the next column. And normally we add, but I don't even need that last column because that's your remainder. So then the 6 is your constant and the 1 gets your x. And my slant is y equals x plus 6. We ignore the remainder. So it didn't say to graph it, but just to give you an idea, a slant would be 1, 2, 3, 4, 5, 6. It has a slope of 1. It would look something like this. And then this would have a vertical asymptote at 0. That would look something like this. And your curves go in opposite corners. So it would either be here and here, or it would be here and here. And I'd need additional information to figure out which one is which, but that's what they will look like, opposite corners.
For the slant, like, do you know if it's going to go like this?
It would depend on what this first sign is, if that would determine if it's positive or negative slope.
So if it was a negative.
Correct. Yep. All right, example 7, find the slant asymptote of the function. Again, my numerator is 1 more than the denominator. Can I use synthetic this time? Why not? Because the bottom is not raised to the first power, right? It has to be x plus or minus something. So in my numerator, I've got to add in a 0x squared and a 0x. So I'd get x to the third plus 0x squared plus 0x minus 1 divided by x squared plus 2x plus 2. And then it's first into first. So I have to multiply x squared by x. I'd multiply all 3 parts. So x to the third plus 2x squared plus 2x. Change your signs. These cancel. Negative 2x squared minus 2x. I bring down the minus 1. And I repeat the process. What would I have to multiply x squared by to get to negative 2x squared? Negative 2. Multiply it times all 3. Negative 2x squared. Negative 4x. Negative 4. Change your signs. As long as that first one cancels, I don't even need to look at the rest because the rest is the remainder. And I ignore the remainder. So then my equation is literally my quotient equal to y. Questions on that one? All right, now example 8 puts it all together. We're actually I added on some examples after this, but we're gonna put this all together because I wanna combine what we did yesterday and what we did today. So it says find the horizontal, the vertical, the slant, the holes, graph the function, and then we're going to use the graphing utility to verify. So first of all, if this is, we're starting from scratch, so pretend this is on your quiz for tomorrow. Where do you start? It's the very first thing you got to do. Before you can do domain, yes, you're going to do domain, but what do we do before we get to domain? Factor, top and bottom. So in the top, x and x, factors of positive 4 that sum to negative 5. Negative 1, negative 4. Factor the bottom. This is the difference of two squares. So x plus 2, x minus 2. Is there going to be a hole? No, okay? So before I do, my domain would come first. I would still say that neither of these can equal 0, so x cannot equal negative 2, and x cannot equal positive 2. And that leads you to your domain. So domain, negative infinity to negative 2, negative 2 to positive 2, and 2 to positive infinity. And that might be the only thing that question asks, but then they're going to ask you other parts of it as well, and there's going to be questions where you have to pick your graph. So we're going to go all the way through. That's our domain. Our vertical asymptote is the exact opposite of that. So instead of it being not equals, it is equals. So the vertical asymptotes occur at x equals 2 and x equals negative 2. Then I'd go horizontal asymptote. Well, first then I'd see right here is when I would see if I could cancel them out. Before I got to that vertical asymptote, I would ask if you could cancel something out then. We already said you couldn't. If you could, that means there's a hole and it means it affects the vertical asymptotes. Okay. Now go horizontal asymptote. What's the scenario with n and m here? They're equal, which means my horizontal asymptote is 1. The leading coefficients, 1 over 1. Is there a slant asymptote? No. Can't, because if there's a horizontal, you can't have a slant, but also the one in the top has to be 1 more than the one in the bottom. The other thing it's going to ask you for is your zeros. Whoa. That's fun. Okay, I'm just going to rewrite it. All right, then you can start to graph based on this. We're going to need more information, but we can start. So I'd get negative 2 vertical asymptote, positive 2 vertical asymptote, and y equals 1 horizontal asymptote. Then I would say you also need your zeros and your y-intercept. So my zeros are going to come from my numerator. My zeros are at 1 and 4. Which tells me for sure the bottom right, I'm cutting underneath my horizontal asymptote. That's for one thing. I know it's got to cross through somewhere in the middle there, and then they can't all go in the same spots, which typically means that this is happening, especially because there's no other 0 here. I know that at least that corner is happening. Now I want to establish more of a shape in there in the middle, so another way to do it is find your y-intercepts. So my y-intercept, I plug 0 in. Everywhere there's an x, and I get 4 over negative 4, which is negative 1. So negative 1, 0, negative 1 is a y-intercept. Now if I think my shape is going to be cubic in the middle, but if I want to be sure, I'm going to plug in negative 1. So I get negative 1 squared minus 5 times negative 1 plus 4 over negative 1 squared minus 4. 1 plus 5 plus 4 over 1 minus 4. And I get 10 over negative 3, or negative 3 and 1/3. So it confirms that shape in the middle takes on that cubic shape. And if you were unsure about the left side, like if you were confused, you weren't sure about the zeros, you can always plug in something to the left of negative 2. But the fact that it did not have another 0 confirms that it didn't cross through that x-axis. All right, it says use a graphing utility to verify, so let's practice it, okay? Again, this will not be something you will get on your test, on your quiz tomorrow, but it is helpful. One, if we're checking homework. Two, on the test, you might have a question in which it asks you to graph it, okay? So we're gonna graph that full function. All right, this is what my graphing utility showed up with, okay, which confirms what we found. So remember, you won't see your asymptotes, you won't see the lines, okay? If there was a hole there, you wouldn't see the hole. You've got to know that it's there. Questions on that one? So everything in this question is fair game for tomorrow's quiz. Vertical asymptotes, horizontal asymptotes, zeros, y-intercepts, domain. We will save slant, because it wasn't in this one. Slant and holes will be on your test, but everything that we just went over right now could be on tomorrow's quiz.
Are they multiple choice?
Some are, no, they're all multiple choice, yeah. Some graphing, some will just ask you for the intercepts, or just ask you for the zeros, just ask you for the domain. But then there's ones that'll just say, like, literally pick which graph it is. Yeah. All right, add these on, because we didn't get practice with the slants and the like graphing with the slants and graphing with the hole, okay? So if you want to duplicate that last slide, you can, like, duplicate the page and change the equation. But there's going to be two that we're going to work through together. So this one I changed to x squared minus x minus 2 in the numerator over x squared minus 4. But we're going to follow through that same process. We're going to identify all the same parts, which means we start with the factoring. So the bottom we already factored. This was the same denominator as last time, x plus 2 and x minus 2. This time the numerator factors into x minus 2 and x plus 2. So why do you think I gave you this one? Because there's a hole there. That x minus 2 in the top and the bottom is going to cancel out, and that gives you a hole, okay? Before we do the hole, we do the domain. So we'd say that these cannot equal 0 before we cancel anything out, because there is still a domain restriction even if it's a hole. So my domain is still negative infinity to negative 2, negative 2 to positive 2, and 2 to positive infinity. And now I have a hole. So now I check for the hole, because the x minus 2's can cancel out, which means there's a hole where x equals 2. So set that x minus 2 equal to 0, solve for it, or just change its sign. And that's the x coordinate of your hole. Now, every other thing from here on out is based on the updated one. My updated function is x plus 1 over x plus 2. I use that for everything else. I'm going to find the y coordinate of the hole by plugging 2 in. So 2 plus 1 over 2 plus 2, and I get 3/4. That's the y coordinate of the hole. I'm going to look for all my asymptotes based on this new updated one.
Wait, so what do you plug the x into for the hole?
The updated one after you cancel out.
The update.
Yep. Then I'm going to go from my updated one and say this equals 0, which means x equals negative 2 is my vertical asymptote. Then I'm going to use the updated one to see if there's a horizontal asymptote. They're both the same exponent. So my horizontal asymptote is the leading coefficients again, y equals 1. And I'm using my updated one to test for slant. There's no slant, because the numerator is not one more than the denominator. And I'm going to use my updated one for the zeros. So I set x plus 1 equal to 0, and my 0 is at negative 1. And I'm going to use my updated one for my y-intercept. I plug 0 in, and I get 1/2. So again, after I get the x coordinate of my hole, everything else is based on the new equation.
Can there only be holes in slant?
No. No, there's no slant in this one. Yeah, no, there can be holes in any of them. Yeah. Okay, so now I'm going to pull in a graph so we can plot what we've got so far. So I have a vertical asymptote at x equals negative 2. I have a horizontal asymptote at y equals 1. no slant asymptote, a 0 at -1, a y-intercept at 0, 1/2, and a hole at 2 3/4. So where do we think the curve on the right is going? Above or below the horizontal asymptote? Where did I just plot all those points? Below. It's going to go below. So it's going to come here, it's going to cross through here, it's going to stop at that hole, and it's going to continue on beyond it. Is there another 0 on the left of my vertical asymptote? No, which means it's not crossing through underneath on that side, right? It means it's going above. How would I confirm it? Plot a point. So pick literally -3, the smallest one you could pick, and you're plugging it into your updated function. So -3 plus 1, -3 plus 2, I get -2 over -1, 2. -3, 2 is where that coordinate point goes, which confirms it's above the horizontal asymptote. Questions on that one? So again, holes next Tuesday. It's going to happen on your test. Be prepared. Okay, and this one. It says find the horizontal, the vertical, slant, and the holes, graph the function, use the graphing utility again. Oh, I didn't use the graphing utility. We were right the last time, I'll tell you. You won't see the hole. That's the only difference. But change the denominator on this one to x minus 3. So x squared minus 5x plus 4 over x minus 3. Get rid of the exponent and change the bottom to -3. Why do you think I did that? This one's going to have a slant. We haven't done that one yet, full out. All right, so first thing, factor, which we already factored the numerator, but it's x minus 4 and x minus 1. Domain comes from the denominator. X can equal 3. So my domain, -infinity to 3, 3 to +infinity. And now we check to see, can it be simplified? Can I cancel anything out? No, which means there's going to be no holes. Then my vertical asymptotes are the opposite of the domain. Where it can't equal it is now where the asymptote goes. So x equals 3. What's the relationship between the exponent at the top and on the bottom? Top is bigger, so no horizontal asymptote. Specifically, how much bigger? By 1, which means there is slant asymptote. And to find it, I divide. Can I use synthetic this time? Yes. So I would take the opposite of the denominator. So 3 goes on the outside. List your coefficients. 1, -5, 4. Bring down the 1. And this, I will tell you, this happened a couple times on your test. Like people wrote that they were bringing down the 1, but then wrote 3 there. So be careful. You brought down the 1. Then you multiply by 3, put it in the next column and add it. Multiply it, put it in the next column. And I would add it, but I don't even need the remainder. What I need is this to get an x. So my slant would be y equals x minus 2. And then my zeros come from my numerator. Set them each equal to 0. And I get 1 and 4. And my y-intercept comes by plugging zeros in, and I'd get -4/3. Now I'm going to plot what I've got. So vertical asymptote at x equals 3. Slant asymptote at y equals x minus 2. So I go down 2. My slope is 1. Now there are 2 curves. You have to find both, okay? Do the holes, would the zeros help? Yes. Look at my zeros. I've got a 0 at 1, and I've got a 0 at 4. And I've got a y-intercept at 0 and negative 4/3, which is like right there. So where do you think these curves are going? They got to cross through those points, right? This one's got to go here. And this one's got to go here. So they hug the asymptotes. They could either be little narrow, like it could have been here, narrow little V's kind of, but fluid. Or they could be really wide, depending on what section they go in.
How'd you get this line?
You divide the top by the bottom. So I divided x squared minus 5x plus 4 by x minus 3. Oh, like just graphing in the line. So it starts at negative 2, that's your b. And then you use your slope, which in this case was 1. Mm-hmm.
Why do we use the leading coefficient to like divide?
Why did you or why didn't you?
Didn't
We did.
we like to use 3?
Because the denominator is this is what it was.
Oh,
Is that what you mean?
yeah.
Yeah. So the opposite of what follows x goes on the outside. Questions? Okay, so again, quiz tomorrow. I have to publish a review assignment. But quiz tomorrow includes zeros, y-intercepts, domain, vertical asymptotes, horizontal asymptotes. And then obviously graphing any of those things, okay?